I'm super excited to be here today. This is my first Monitorama, and I can't imagine a better experience than what we've had so far. My name is Ross. I'm an SRE at Dropbox, and I've been there for about 3 years. And today I want to talk to you about the evolution of our distributed tracing system. So we're going to first sort of level set, figure out like what tracing is. I'm not going to deep dive into it, just sort of a general overview. Then we'll talk through how we actually built our tracing architecture, and then finally touch on some lessons we've learned along the way. First up, what is tracing? At a high level, it's basically how you track time spent through a system. It's request scoped, and it's sort of like, I like to think of it as a cartography for your distributed system. It is building maps as people use it. This data is sampled, not aggregated, so you get the full view of what happened during a request. And you're able to use that to drill down into specific behaviors that happened within that request. And so it's usually built with several different parts. You have integrations within your services. You have the system to transport and store that trace data. And you have something to query that trace data. And then some terminology. Span is a period of time within your request, typically linked to some operation that happened within there with the service. Then you have a trace, which is a graph of spans, sort of linking them together chronologically. Then you have integrations. These are the things that actually create the spans. And these are things within like RPC systems or web servers or load balancers, anything that would emit spans that you want to see. I like to think of tracing in context of like time series databases, something it's not. Now, with time series data, it's aggregated, it's not sampled, and it's counters, gauges, histograms, things you can see over time. And it's great for analysis of trends and figuring out like what's happening in the past, what's happening now. But it's hard to go from seeing this top-level analysis, like what's happening at a high level, to finding the specific instance of a problem. So an example of this. So if we look at this graph, it's a latency graph for an RPC endpoint. We know something is happening there. That latency is quite high. But what is happening? We don't know. We have to go use some other tool to figure that out. With tracing, if you can link those two things together, you now have a way of seeing exactly the behavior that triggered that anomalous graph. And you can drill down and see information about what's actually going on. So that's tracing in general. Let's talk about Dropbox. So we have exabytes of user data, 500 million users. We use 6 programming languages regularly and have millions of inter-service requests per second. What this means for tracing is that we have tens of thousands of spans per second at a 0.03% sampling rate. And this is head sampling, so at our top-level load balancer, we make our sampling decision. We have 200 plus services across 4 languages that we support, and this is all managed by a team of 7. We've built this system out over the course of the last 2 years. And this talk will go into how we've actually done that. First, a little history. So the initial version of tracing, before I got involved at all, was built about 5 years ago. And this system, it worked, but no long-term plan, no ownership. And in the last 2 years, we've gone from totally unsupported to it being a side project to now it has a team of 7 managing it, and it's supported, and it has a long-term goal. So this first version was Zipkin, plus some stuff we had lying around that we combined together. And Zipkin is one of the original tracing systems built by Twitter. Great system, worked pretty well. And we had a few one-off integrations that we built on top of that. So we had our legacy RPC stack and some parts of our web server, but that's it. This was all built on top of our version of Facebook's Scribe technology for transporting logs around. And it looked a little bit like this. So we have a service at the top there. It emits trace data into Scribe. Scribe then aggregates that up into Kafka, and we consume that with a writer process, push that to Zipkin, and finally Zipkin stores that into HBase. So why didn't this stick around? It didn't really reach critical mass. When you're building a new tool, even if it's the best new tool, if you don't evangelize it, you don't make it, have people know it exists and use it, it won't go anywhere. And it was built but not maintained. People built it, threw it out there, and was like, that's it, we're done. And we never really got around to improving it and building on top of it. And finally, there was no real consistent UX for both developers or users. So you couldn't easily reason about how this system worked. So when I came on board, the first thing we did was fix 3 years of bit rot. This thing had been sitting around for about 3 years, and no one had touched it. Parts of their code were deleted. It just didn't work. So we updated the code, migrated to some of the newer Dropbox internal libraries. But this was just a Band-Aid. We knew this wouldn't last for long, so we did research and tried to figure out what was next. Like, what are we going to do after this? So on the path to building a proper tracing system, this time we thought the timing was good. We were moving to a service-oriented architecture overall at Dropbox, and the services we had were multiplying. And people were starting to ask the sort of questions that distributed tracing could answer. And at the time, we couldn't actually answer those questions. So we thought this was a perfect opportunity for us to step in and rebuild the tracing system. And finally, to sort of prevent what happened last time, we set short, medium, and long-term goals. We wanted to quickly sort of build out the tracing system to get people interested and involved, while making sure that we had a supported and long-term plan for the system. So the first thing, there we go. So our short-term goals were to finish stabilizing the system, and then define a set of interfaces for tracing going forward. So first up, stabilization. In our system here, the biggest source of operational load to begin with was this writer process. And this takes from Kafka and commits span data into Zipkin. And it had mostly been deleted. Like, at one point, all the code was gone, but it was still deployed, running in production as like a zombie service, which that's not great. That's a pretty horrible way to run a service. And when we brought it back, basically we put a load through it, and it oomed every 20 minutes. Ran out of memory, crashed continually. So this had to go. We had to fix this if we wanted to get anywhere. And so what we did is we put another Band-Aid on it. We fixed the ooms, added some metrics, brought it more up to date with the stack, and moved on to building the interface. So this is something we didn't really have previously. So if you're using tracing, typically you have like your user code, you have an interface to tracing, and then you have the actual libraries behind tracing. This is something you see in like open tracing, where you have that one standard interface, and then you plug in the actual implementation behind it. For us, we just had tracing. Python and Go had totally different APIs, and it was just sort of like calling into a mess of spaghetti. So what we did is we did some research, and we wanted to build a consistent sort of user experience for tracing. So we looked at open tracing, we took a subset of that, and then implemented that as our sort of interface for people to use. And this hid all the complexity of the actual tracing implementation behind our interface, and also specified what a tracing system is. So we knew what we had to build. So now that we had sort of shored up the ingestion pipeline, we knew what tracing should look like, we had to start actually adding value, building on top of tracing. So we decided to build new features and tools. This is new integrations, fix up the old ones, and also switch off of Zipkin and HBase. So first off, integrations. These are the things that actually emit your trace data from your processes into some sort of trace system. And we had two main languages at the time, Python and Go. And like I said previously, they had totally different APIs. They were just different, like not even close to anything you'd see in like open tracing or open census. So first thing we did was get feature parity there, make them the same, make them consistent. And we also have three main transports that we wanted to trace. HTTP coming in from users, legacy RPC, which was just protobuf over HTTP, and Courier, which is our service framework around gRPC. So we built out features for those, made sure people could see traces for all those systems, and we moved on. This gave us really good coverage right off the bat. So we could see most of these RPC calls within our service, within our system, without having to do too much more. And this gave developers a lot of value early on, so we could keep them happy while we rebuild everything else underneath it. So next up, we moved off of Zipkin. So Zipkin is a great project, and I like it a lot, but we couldn't really deploy it anymore. We used a really old version. using a legacy build system. And Zipkin plus HBase is kind of a weird combo. Most people use Cassandra or Elasticsearch, but we used an unsupported plugin that let us use HBase. And since it was unsupported, we would have to maintain that going forward. So we took the opportunity to look into other solutions. And we looked into Jaeger. Jaeger's a newer project, but has a lot of momentum. And we knew some of the folks who built it. And the best part was it was written in Go, which Dropbox has a lot of knowledge about and a lot of support for. So we were confident that we could build on top of that and easily support it in the future. So the first thing we did is, because we're using Kafka, we could just tap off to the side and try it out. And we used Jaeger plus its in-memory storage system. And this let us sort of try before we buy, make sure that the system could work, people could use it, got value out of it. And finally, when we had sort of figured out if it would work or not, we switched to Cassandra as our persistent storage backend. Now, we used Cassandra instead of some of the other options because other teams at Dropbox had recently started using Cassandra, and we could piggyback off of their expertise to sort of bootstrap ourselves easy. So now we have a better UI. We have a mostly working ingestion pipeline. Well, what's next? So unfortunately, the data model we had internally behind our tracing interface wasn't quite up to snuff. It didn't work as well as we'd like. And it was, there was a huge impedance mismatch between what systems like Jaeger or Zipkin expect and what this data model actually looked like. So we had this huge, multi-100-line function that went from our weird model to something vaguely standard, which wouldn't scale. The other issue we had was operational problems with Scribe and Kafka. We had a lot of issues load balancing and maintaining our throughput through these systems. Part of this was Scribe and Kafka, part of this was our writer process. And then finally, the other problems we had were our tracing integrations were high overhead. Tracing lives in the critical path of your system. If it has high overhead, people aren't going to want to use it because it's going to cause high tail latencies, which is no good. And in worst case, we would add several milliseconds to trace requests, which is absolutely unacceptable. So we couldn't really scale the system to higher sampling rates because people would start complaining. So the solution was to just remove everything that we didn't like. So get rid of Scribe and Kafka, get rid of the writer process, and rethink it from scratch. So what we did is we traded off the durability of Kafka for simplicity and performance. We would maintain back pressure by removing that queue, and we still use small fixed-size buffers to handle the load spikes we get periodically. And it looks a little bit like this. We call this system Kaiju, and basically, it looks a lot like other trace systems like Jaeger's. And you take trace data from a service, you push it through gRPC to an agent process living on every machine. It buffers that, pushes it up to the aggregator tier, which then commits it to Cassandra, which Jaeger can then query from. So how do we get there? We're ripping out a pretty major part of our stack. This isn't something you can just do overnight. So we decided to incrementally replace it. We have that nice interface boundary, so we could take the opportunity to hollow out what was underneath there, put in the new Kaiju version, and hopefully the users would be none the wiser. So the first milestone we did for this was to take the service to Scribe communication out of the loop and put the agent in there in its place. So this lets us exercise it basically lets us figure out how the system would work without having to totally remove the Scribe and Kafka pipeline. But we did remove Kafka and Scribe from the critical path of Dropbox, which fixed the issue we had with high tail latencies caused by tracing. The other thing this gave us was the agent is a new global deployment. And this is something we deploy to tens of thousands of machines and would run and interact with every process on those machines. So we wanted to do this slowly and make sure that we didn't break anything. And the result was really good, actually. So we rolled this out, used feature gating to slowly turn off the original system, switch on to the new Kaiju-based one. And despite you see that giant dip there, that's actually monitoring problems, not the rollout problem. Don't mind that. And we saw really good latency improvements. Basically, overall, the system worked as we intended, and no surprises. So now that we had the agent in place, we knew that the system mostly worked, we had to do the big part, which was remove Scribe and Kafka and switch to this new aggregator layer. Unfortunately, I can't tell you the result of this. We had just started this as I began to prepare these slides. So look forward to a blog post sometime later this year where we share if it blew up or not. Crossing my fingers it does not blow up. Yeah, so we expect better load balancing, better span ingestion, just a general performance improvement and increased reliability. So now let's pretend that the system is deployed and works and is going as we expect. And now we have, what do we do next? We have all this trace data, and we need to do something with it. We can use the UI that Jaeger Zipkin provides, and that's nice. But we have this data. We should be able to build new things on top of that. It's kind of a waste if we don't go deeper here. A couple things here, dependency graphs, derived metrics. Like, how do we find the weird things that are going on in your system? If anyone's used the tracing systems that are available open source, it's very hard to find that one weird trace unless you explicitly trigger it. And one of the things we want to work on next is actually figuring out those things automatically. How do you make that link between the weird anomalous graph and the weird anomalous trace? So finally, we want to go through lessons we learned. So first up, start small, build momentum. This project was totally unknown, and then we took it on as a side project. And finally, it ended up actually being invested in and being turned into something we support with a full team. And that gave us a lot of opportunity to sort of build and grow as we went. Next, even if you start small, you need to invest. Tracing isn't something you can just sort of build once, forget about, and then hope it works. You need to actually go through, put the integrations into the key components of your systems in order to get consistent, reliable traces. And then you have to put people around that system. You can't just throw it out there and hope someone else does it. You need to actually invest the time to support the system and build out new things on top of it. Next up, one thing we learned was because we integrated tracing into our service framework, this is the framework that we use for all services at Dropbox, we got really consistent, really good traces right off the bat. With this framework, pretty much everything uses it. We got universal adoption of tracing basically for free. If you deployed with Courier, which you were highly suggested to do so, you could go to tracing right away after you deploy your application and see traces filter in. And this basically prevented us from having to chase people down to add instrumentation to their systems. If they deployed it as they should be deploying it, we got it for free. Finally, or probably not finally, but so have a solid interface for tracing. This system is pretty complex. There's a lot of depth here. And if you have a solid interface there, it makes it really easy for your developers to reason about and hide the underlying complexity. Well, I mean, for example here, one user was expecting it to take weeks to integrate tracing with one of our database systems. He looked at the API, and he ended up doing it in like a couple days. Without the sort of consistent UX that people expect, it's going to be way harder. So to wrap up here, distributed tracing fills a valuable niche. It's something you can use to drill down into weird behaviors of your system. It provides something that time series data does not. Define a clear, consistent interface for your tracing system. There are good open source options. Build on top of those. And then start small, build value in your system, and then invest fully. And that's all I have. Thank you very much. So the timer here says 30 minutes, but I think I am a little under that. So if we have time for questions. Yeah? Any questions? Yeah?
And this is for the team you were talking about. Is that a team that's having with broader responsibilities, or is that team just working on the tracing infrastructure?
Yeah, so we have broader responsibilities. We have 2 main projects and a couple smaller ones, but most of the team for the last year has been on tracing. All right. Thank you very much.